All right, greetings everyone. This video is to go over some of the prereq material we'll need for section 2.1, and really a lot of what we're about to go over here is going to apply broadly to chapter 2. I'll also let you know as I'm going through this that the section 2.1 prereq practice, now all the stuff that's on there relates directly to what we're about to do, but it's a different set of skills that we'll need for chapter 2. Okay, so first we're going to go through these first 4 problems. So it says in number 1, given the coordinate points 5, 1 and -10, -5, find the average rate of change between the 2 points. And we know how to do that. We've done a bunch of that in chapter 1. So we know we can use, sorry, not m equals. We can use the formula rate of change equals, and in this case, since they just gave us points, we could call them y2 minus y1 over x2 minus x1. And let's see, I'll call the first set here, this will be my x2, y2, I know that's really hard to read. And the second one here will be the x1, y1. So now if I plug those into the formula, we'll have 1 minus -5, make sure we do the minus minus there, over 5 minus -10. Okay, and when we do that, we'll end up with the 1 minus -5, that makes a plus, so we'll have 6 on the top, over 5 minus -10 makes 5 plus 10, which gives us 15. And then 6/15, that can be reduced to 2/5, right, if we divide both of those things by 3. So it looks like our rate of change between these 2 points, our average rate of change, would be 2/5. Okay? Now the second question says, assume that those 2 points lie on a straight line, and there's a special name for the average rate of change between any 2 points on a line. What is that name? So I think we've talked about this a little bit earlier in the quarter. Chances are, if you've taken an algebra class prior to this, you've heard this term before, and that term is slope. Okay, so when we're looking at linear functions, we have a special name for the average rate of change between 2 points, and again, that's going to be the slope. All right, and then part 3 here says, use your answer from problem 1 along with one of the points from problem 1 to find the equation of the line between the 2 points. So we've also looked at this before, so recall that our general form for the equation of line, or one of the general forms, is y equals mx plus b, where m is your slope, which we already have, right? So that's 2/5. And then we have to find the value for b, which is our vertical intercept. And as the instructions say, the way we can do that is to choose one of our points, and it turns out it actually doesn't matter which one we use, so I'm going to use the point 5, 1. So I'll plug in the different values where they go, so know the 5 is an x value, the y, or the 1 is a y value. So this should be set up as 1 equals 2/5 times 5 plus b. And now I can solve this for b because it's the only variable. I can make my 5 here a 5 over 1, and then notice I have a 5 in a numerator and denominator there, so they can cancel out. And when I multiply that fraction, then I'd end up with 2 over 1, which is just 2. So now our equation looks like 1 equals 2 plus b. We can solve for b by subtracting 2 from both sides. And then when we get b equals -1. Okay? So we can use that information for a line, which will be, in this case, y equals 2/5 x minus 1. Right? And that's our equation of our line. Cool. All right, and the last thing for this first set of problems then is to graph the line on this set of axes. So again, our equation was, sorry about that, y equals 2/5 x minus 1. And as I mentioned, this value for b right here, that -1, that's our, and I'm going to do v dot I to mean vertical intercept, which means it's going to be the point where the line intersects the vertical axis. So we can go ahead and put a dot there for -1. And then our slope here being 2/5. Well, one way we can interpret that is as rise over run. So it tells us from point to point how much the function goes up and over. So that's what the rise and the run. So to draw another point on a line here from the where that -1 we marked is, we can use this slope to draw another point. So we can go from there, from that point -1, we can rise 2. So that's what the rise means. And then run 5. And we always run to the right. Okay, and put a dot here. And we could connect those dots to make our line. We could also go back the other way, kind of drop 2 and go to left 5. And if we do that, we'd get another point here. But what's most important then is we can go ahead and connect these dots like that. Not like that. That's terrible. Sorry about that. Let me try again. Oh my gosh. Okay, Cody, get it together. Sorry about that, y'all. Here we go. Okay, now I can draw my line. Okay, going through those points, and then recall whenever you draw a graph of a function or line, if it does not stop at particular points, we need to include arrows on the ends. Okay, because it does stretch forever in each direction. So this green line here would be our line. All right, moving right along. On problem 5 here, we're given a table of inputs and outputs. And notice here, the left-hand side, all these t values, those would be the inputs. The v of t's here would be the corresponding outputs. And we're asked to find the average rate of change for this function over each of the indicated intervals. So we've got -4 to 0, -1 to 0, and 2 to 5. And first of all, remember that this -4, 0 right here, right? That's not a coordinate point, that's an interval of inputs. So going from -4 to 0. And if you recall in our lesson about average rate of change, we can think of this as A, comma B. Okay. And if you recall, to find the rate of change over an interval, one way to do it is to do f of b minus f of a over b minus a. Here, because I'm using v's, I'm going to use, or my function's called v of t, I'm going to do v of b minus v of a all over b minus a, which then we can plug in the information we have. So the value for b is 0, minus value for a is -4, 0 minus -4. From our table, we see that v of 0 is 4, so the output there is 4, minus v of -4 is -4, all divided by 0 minus -4, that'll make 0 plus 4, which is 4. 4 minus -4, that gives us 4 plus 4, which is 8, over 4, which just becomes 2. Okay, so we see that our average rate of change on the interval from -4 to 0 is 2. All right. Now, I'm not going to go through that calculation for these other two intervals from -1 to 0 and from 2 to 5. You can double check that yourself. And hopefully when you do that, what you will see is that every time you get 2. Okay? And so this ends up being something we'll talk more about in section 2.1. But for a linear function, one of the defining characteristics of it is that regardless of what interval you look over, whenever you count the or calculate the average rate of change, it's always the same, which is kind of cool and makes linear functions a special type of function to study for us. All right, last thing is just some more practice with finding values of variables. And in this case, we have some equations here where we're given the value of one variable or more, and then we're asked to find the value of another variable. Okay, so for example, in the first one, we're told to find y when x equals 2. So here we have the function, or the equation y equals 7x minus 1. We've been told the value for x, so we can go ahead and plug that in. So we have y equals 7 times 2 minus 1. And then notice from here we can very simply solve for y, right? Because the y is already isolated. So all we have to do is work out the algebra on the other side, or the order of operations. So 7 times 2 gives us 14 minus 1. Here we get y equals 13. Okay. All right, I'm going to skip down to letter C here. And now we're asked to find t when the value of v is negative 2. And our equation in this case is v equals 3/7 t plus 4. Now notice in this case, the value of the variable we've been given is the one over on the left-hand side here, right? So we can go ahead and set up our equation that way. So plug in the negative 2 for v. We have negative 2 equals 3/7 t plus 4. And then we need to isolate the t. So in order to do that, we'll start by subtracting 4 from both sides. So these will cancel. Negative 2 minus 4 gives us negative 6 equals 3/7 t. And I know we see fractions, immediately our heart rate elevates and we start to get really nervous, but don't worry, we can handle this. So we see that the 3/7 is being multiplied by the t, so to isolate the t, we're going to divide by 3/7 on both sides. Okay. When we do that, we've got t equals, and we have negative 6 divided by 3/7. And do we all remember how we divide with fractions? And I know your hand is moving towards your calculator right now. Resist the urge. You don't need your calculator. We're going to do this without it. So when we're dividing with fractions like this, the first thing we need to do is make sure that both things are fractions. So we have a negative 6 divided by 3/7. We're going to write the negative 6 as negative 6 over 1. And then depending on maybe where you went to high school or how you learned fractions, one kind of memorization tool for remembering how to do this stuff is keep, change, flip. So what that means is keep the first fraction, so negative 6 over 1, so keep it as it is. Change means change division to multiplication, so now we're going to multiply. And then flip means flip the second fraction. So instead of 7/3, we're going to multiply, or excuse me, 3/7, we're going to multiply by 7/3. So now it becomes negative 6 over 1 times 7 over 3. And then what we can do before we multiply is we can actually do some reducing, because notice that there's a 3 here and a 6 here, and those are both divisible by 3. So I can divide this 3 by 3, which gives us 1, this 6 by 3, which gives us 2. And then when you multiply fractions, you multiply straight across. So we do negative 2 times 7 across the top, which gives us negative 14. 1 times 1 across the bottom, which gives us 1. And so we end up with negative 14 over 1, which is just negative 14. So the value for t here is negative 14. Okay? All right, as per normal, if there was something that tripped you up or that you're unsure of, you can go back in the video and check it out. I'd also make sure that you have these operations with fractions down, because this is not the last time you will see them. Okay, thanks for watching.